In this class, we'll see the doubt clearing session. Many of the students having doubt in a complex stress problem. While you are drawing the Mohr circle for a given plane stress condition, you people get confusion in the sign conversion. So in this class, we'll see the sign conversion for a complex stress problem. Whenever, if you see complex stress problem, there will be a two-dimensional plane body. If it is subjected to, for example, if it is subjected to a stress like this, we consider it as the tensile stress. Sigma x, it is tensile in the sense. Again, we consider tensile as positive. Again, this is again in stress in y direction. We consider stress in y direction. This is again tensile in nature, so we take it as positive. There is one more condition, like if a plane subjected to, the stresses like this, if a plane subjected to stresses like this, then the sign conversion will be like this. Like this will be sigma x, which is tensile in nature, so we consider it as positive, and this is sigma y, which is compressive in nature, so we consider it as negative. So this is the normal sign conversion. So many of you people know about this. And one more doubt is, like, while you take a two-dimensional body, a plane diagram, if the shear stress is acting in this direction, then we consider this as positive tau xy. Tau in a sense, shear stress in xy direction. Shear stress in xy direction. This is also the tau xy. We consider this as positive shear. The value, whatever the value, if it is 60 megapascal, then we consider it as positive. If in case, if you have a plane body like this, if the stresses are acting, if the shear stress is acting in this direction, then we consider this as negative shear. Tau xy is negative. Whatever the value we get here, this will be negative shear stress. Then there is one more doubt which the students usually get confused here is, like, for example, if you have a plane body like this, like if it is subjected to the stresses, along with this, if it is asked to determine the normal stress and shear stress on a plane which is inclined at an angle, for example, at an angle theta, let us assume this angle as 60 degree. Then what is the value of theta we need to take here? What is the value of theta I need to consider? So while we are deriving the equation for this plane stress condition or complex stress condition, what we do, we derive like this, like we derive with respect to vertical plane. So this is our horizontal plane, this is our vertical plane. While we are deriving the equation for a normal stress and shear stress on a plane, we get normal stress perpendicular to this plane and the shear stress parallel to this plane. Normal stress perpendicular to this place and shear stress parallel to this plane. The thing is, the students where you people get confused is like whether I need to take theta as 60 degree or 30 degree or 90 degree. This will be the confusion. So how to avoid this confusion in a sense, whenever the angle is, if the plane is inclined with respect to horizontal plane, if a plane, let us call this as plane AB, if any plane AB or any plane which is inclined with respect to horizontal plane, the plane AB is inclined with respect to this horizontal plane at an angle theta. But this theta, whatever the theta we need to take is, it should be inclined with respect to vertical plane. It should be inclined with respect to vertical plane. Means I need to take this as theta. This is our theta which I need to consider here. So this theta we should not consider, because while we are deriving the derivation for the normal stress and the shear stress, we consider theta with respect to vertical plane. So this theta you need to consider. So again, how to calculate this theta? Again, it is simple. So if it is 90 degree, 60 minus theta will be 60 minus theta will be 30 degree. Again, there is a confusion whether it is a positive theta or negative theta. So if with respect to vertical plane, if this plane AB is making with respect to vertical plane, if it is in anti-clockwise direction, it is positive. If it is in anti-clockwise direction, it is positive. If in case, one more example I'll show you. If you have a plane like this, for example, here if we have a plane, let us call it as plane AB. If it is inclined at an angle 60 degree over here, 60 degree over here, then as you people know, the normal stress will occur perpendicular to this plane. Normal stress will occur perpendicular to this plane. Where it occurs? It occurs in this direction, perpendicular to this. And the shear stress will occur parallel to this. Either it may be like in this direction or it may be in this direction. It depends on again the value which we get. So now again here in this problem, if you see in this problem again, the theta is 60 degree with respect to horizontal plane. This is our horizontal plane. This AB, this plane AB is making at an angle 60 degree with respect to horizontal plane. But we should consider, we should take a theta with respect to vertical plane. This is our theta. So this is nothing but 30 degree. This is 30 degree with respect to vertical plane. With respect to vertical plane, it is 30 degree. Now it is in which direction? It is in clockwise direction. It is in clockwise direction. Clockwise 30 degree. Clockwise in the sense negative. So negative 30 degree. So theta I should consider minus 30 degree in this condition. Again, in some problem they may give like this. There are many different conditions. Like in some problem, it has been given like this. A plane we have here, then here we have an inclined plane, which is making an angle of 30 degree with respect to horizontal plane. Let us call this as XY plane. Now the value of theta, now it is making 30 the XY plane is making 30 degree with respect to horizontal plane. With respect to vertical plane, it should make 60 degree, right? It should make 60 degree. Now tell me whether it is clockwise or anti-clockwise. Now here if you see, it is anti-clockwise direction. Anti-clockwise direction in the sense positive 60 degree. Our theta value of the theta is positive 60 degree. Clear? So apart from this, there is one more condition in that they may ask like this. Like if there is a plane, on this plane, like here we have a plane which is inclined at an angle 60 degree. The plane is, you can call it as SS plane or SY plane, or you can take any plane. If it is 60 degree, then what is the value of theta? Now you see here, this SS plane making it is inclined at an angle 30 degree with respect to vertical plane. So directly I can take theta as 60 degree. But whether it is a positive or negative, so here it is in which direction? It is in counterclockwise direction. Counterclockwise direction in the sense, again it is positive 60 degree. It is positive 60 degree. I hope so it is clear. Like in some problem it has been given in some numericals. There is a two-dimensional body which is subjected to the stress like this. Stress like this. Here the stress like this, and which is at an angle of, it is making an angle of, for example, if it is making an angle of 60 degree and its magnitude is 100 megapascal. Again here same, it is making an angle 60 degree and its magnitude as 100 megapascal. Then in this type of numerical, first thing what I need to do, it is not a plane, it is the stress here. It is stress which is acting in at an angle 60 degree, which is acting at an angle 60 degree. In this condition, I need to resolve this stress with respect to in vertical coordinate, in horizontal coordinate. I need to resolve this stress vertically and horizontally. If I resolve this stress, I get these values. I get these values. So if you resolve, we get the stresses like this. So this will be 100 sine 60. This shear stress will be 100 cos 60. So if you simplify this, you will get 100 sine 60, you will get 86.6 here, and 86 here you will get 100 cos 60 will be 50. Here we will get 50. So then you can write sigma x as, then you can write sigma x as, then you can write sigma x as 86.6, and here you have tau xy is 50 megapascal. So this is how you need to approach with this type of problems. So these are the doubts usually the students has while while you are solving the numericals. So these are doubts, clarification of doubts in module 2 complex stresses. If you have any further any doubts, you can comment below so that I can answer for those also. Thank you for watching.